Good evening, students. So today we are going to see what is meant by random variables. So this is the second half of the unit. So we are going to deal with random variables. So in the first half, we have seen what is meant by the basic definition of probability, what are all the different kinds of event, impossible event, sure event, then mutually independent, mutually dependent events, mutually exclusive, all these things we have seen in our previous classes. So in this session, we are going to see what is meant by a random variable. Okay, so a random variable is just a function. First we have to know this random variable is just a function that assigns a real number, for example, if you are taking x, it assigns a real number for every element of S. Okay, suppose S is your sample space. Okay, for each element in the sample space, we have a function which will assign some number. That number is called as random variable. Okay, corresponding to the random experiment. So obviously, what is the outcome of this? So the outcome may be numerical. Okay, outcome of this random experiment may be numerical, and sometime it is going to be non-numerical. It depends on how you define. Okay, so the next concept, okay, while I give you example, you can understand. The next concept is called as range space. So what is meant by range space, students? So now, as I said, for each sample in the sample space, we are assuming the function, it will give some number. Okay, the collection of all these numbers is called the range space, and it is defined by Rx. Okay, the collection of all this data is called as range space. Okay, I'll tell you in a simplified way because we don't have proof of all these things. We in our syllabus, prescribed syllabus, we have only formulas and problems to solve. Okay, I will give a very elementary example so that you can understand what is meant by random variable, what is meant by range space, everything. Okay, now we'll take two coins. So two coins are tossed. Okay, two coins are tossed. So what is the outcome, students? So when two coins are tossed, what is the sample space? So they are head, 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 tail, tail, head, tail, tail. Am I right? So these are all the four possibles. Now x, as I said, I am going to define this x. X is my favorability event. I want something. So I am saying x denotes number of heads. Okay, x denotes number of heads while you toss two coins. Now you see, now I am going to check the value. So what are all the data in the sample space? You can see. So in the sample space, okay, I have four data over there. Okay, let me write like this. Okay, what are all the data? Head, 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 tail, tail, head, tail, tail. So now x denotes the number of heads. So in this event, I have two heads. Here one is head, one is tail. I have one head. Here tail and head. And here there is no heads. So you see this x assigns the values. What are all the values is assigned by x? They are simply 0, 1 and 2. Okay, students. So now you see the values are 2, 1 0. Okay, repetitions you don't bother. Now the collection of all these numerical values, the numbers, this is going to be the range space for this two coins are tossed. So this Rx is a finite set because you will have infinitely many events, okay, that doesn't matter, but it is going to be finite because we are going to assign some numbers according to my convenient what I am feeling. So now it is important to see how this random variable are going to split. So random variables are, okay, sorry, some typo. Yeah. Random variables are two types we can see. The first one is discrete. The second one is called as continuous random variable. So for convenient, I am writing like RV. You should understand RV means random variable. So there are two kinds of random variables. One is discrete random variable and the other one is continuous random variable, guys. So now when we express this discrete random variable for probability, we are going to write like this: probability of capital X, this is a random variable, is equal to xi, or simply we are going to express this as small p of xi. So in this case of random variable, we say this as PMF, probability mass function. Okay. So when you going to come for continuous random variable, we know, we already speak a lot of story about what is discrete, what is continuous, functions, all these things. When you come for continuous random variable, we are not using probability of xi, it cannot be used for particular. So we are taking a function f of x. Okay. So this is called as PDF. Here we have PMF, probability mass function. For continuous case, we have probability density function. So this is called as PDF. That's it, student. So now we have to identify which is a discrete, the random variable is whether it's going to be discrete or continuous. So if it is continuous, in this case we are going to use the integration, guys, with lower limit and upper limit. For the discrete case, what we are going to do, since it is discrete, we are going to take summation. Okay. Now I think I have given you a clear picture about your discrete and continuous cases. This will give you the clear picture about what is meant by random variable, what are all its types. When you express the probability for discrete random variable, we are going to use PMF, probability mass function. For continuous case, we are going to use probability density function. So now let us go to data one by one. So suppose you need some example for discrete random variable and continuous random variable, I can give you some. So for a simple example, you take number of printing mistakes. Okay. So the number of printing mistakes in a book. So you see this is going to be finite, right? It's going to be finite. Or number of telephone calls which you have received in the office. These things are finite. Okay. So how can I say technically, like with proper definition, how can I say a random variable is said to be discrete if it takes finite number of values. Okay. If you want to say a random variable is discrete, it should take finite number of values. Okay. Or it should take countably infinite values. So the range space, Rx should be either finite number of values or countably infinite. Then we can say this as discrete random variable. If it is not so, then obviously what we can say this as continuous random variable. Okay. So in discrete random variable, like it assumes each value has certain probability. For example, you are taking some x 0, 1, 2, 3, 4, 5, 6, etc. So this probability of x you will have like, okay, let me erase this, it will be awkward. So this will be 1 by 2, 1 by 3, 3 by 7, 5 by 6. So for each particular value, the probability will be assigned. But in the case of continuous, you cannot say this, because for a certain value, I cannot say the probability. Okay. So we have just said probability mass function. So one by one, we will see PMF, probability mass function. So as I said, so either I am going to use, see, I am just giving the notation, capital X equal to Xi. Otherwise, you have to use simply probability of Xi. This is called as probability mass function for particular value of X. Here Xi. Okay. So now, very important part A question. What are all the properties of probability mass function? So the properties of probability mass function is always it should be positive, because we know that probability lies between 0 to 1. So it is going to be greater than or equal to 0 for all the values what we are taking. I is equal to 1, 2, 3, etc. Now, second one, as usual, I think you people have guessed. What is this? Sum of probabilities. So I equal to 1, or even it goes to infinity, it doesn't matter. So always the sum of probability is 1. So these are all the two important conditions that probability mass function should hold. Hope you understand. The next concept is called distribution. This is very simple, guys. Probability distributions. Okay. Now I am taking Xi. For this I am having probability mass function P of Xi. So this collection is called as probability distribution. So this is called as probability distribution for the random variable X. It is very simple, student. So usually people define this like people represents this data in terms of a tabular form. It will be easy. So x1, x2, x3, some values. Okay. So corresponding probability of x1, probability of x2, probability of x3, etc. That's it. So this is called as probability distribution. So given data, you have to take the xi as the first row. Okay, you have to take this as first row, and in the second row you are going to take the corresponding probability mass function for each value. That's it, students. So these are all the basics. Once we understand this basic, then problems are nothing like you can solve like anything. The next concept is called as CDF, cumulative distribution function. Sometimes simply people say it as distribution function. Whenever you see distribution function, that means it represents cumulative distribution function. Okay, don't get confused with density function and distribution function. So distribution function is very interesting. What we are going to do here, you are going to take probability of x less than or equal to Ex. So that means, first let me explain you in a layman way. Suppose if we have 1, 2, 3, okay, here probability of x is 1 by 2, okay, let me take 1 by 4, 1 by 4, something like this. Now, probability of x less than or equal to x, what is the meaning of this is, suppose if I take probability of x less than or equal to 3, that means, okay, I will take 2 for example. If I am taking 2, so x less than or equal to 2 means 2 will be included, 1 will be included, 0 will be included. So the formula is simply x equal to 0, x equal to 1, x equal to 2. If the probability of x is 1 means, you can able to see that is going to be 0 and 1. So you have to add this. Probability of x less than or equal to 3 means you have to add all 3. If it is 2 means you have to add up to 2, etc. Is it clear? So now in this case, suppose if they are giving you probability of x less than or equal to 1 means you have only 0 and 1. That's it, students. Now let us come back to the CDF. Now you understand what is happening here. So the cumulative distribution function, how I am defining is capital F of x. This is nothing but probability of x less than or equal to x. Okay, so this is going to be a value. So if I say f of 2, then you have to add up to 2. It's not 0 like from the table. So you have to add all the values from the left hand side. Okay, if it is 0 to 5 means f of 2 means you have to add 0, 1, 2, less than or equal to 2 means. Okay, this is called as cumulative distribution function, guys. So this is very, very simple. Okay, now let us see some part A questions. Properties of cumulative distribution function. So what are all the properties of cumulative distribution function? So let us see what are all the properties. As usual, I said probability starts from 0 and ends at 1. So this cumulative distribution will also follow this. It starts from 0 and it ends at 1. Okay, but we are taking x here from minus infinity to infinity. This is my domain. Okay, so x belongs to minus infinity to infinity. So I can say probability of minus infinity, f of minus infinity is going to be 0 and plus infinity is going to be 1. So if they ask you in part A question 2 mark, you have to write like this. Okay, then third point, whenever there is a value x1 less than x2, then when you calculate the cumulative distribution function, capital F of x1 is also follow the same. Okay, that means it is increasing function. Okay, it will not change. And finally, we have one relation I already said to you. Capital F of xi, some values, nothing but probability of xi. Okay, I will give in the other way. Okay, that will be easy for you. So probability of xi, it is going to be, if I take f of xi minus f of xi minus 1. If you subtract these two values, you will get the probability of PMF of that particular x. So these are all the very basic things about discrete random variable, guys. Now let us go to the very important session, that is tricks and tips. Okay, because this will help you a lot. For example, I will explain through example, that will be better. So I am taking x 0, 1, 2, 3, 4, 5, 6 and 7. Okay, probability of x. I'll take some value randomly, okay. 1 by 2, 1 by 3, 1 by 2, 1 by 5, 1 by 3. Okay, just I'm filling something randomly, okay. 2 by 3, 2 by 5, 3 by 7. Now you can see this is my table, guys. Now people are telling me to find what is the probability greater than 1. In this case it is a headache for me. Greater than 1 means I have to take 2, 3, 4, 5, 6, 7. So that means it is very tough. Left hand side is very easy. Now I have to add 2, etc. up to 7. So now there is a formula. It's very simple, nothing. Sum of probabilities are always 1. Using this trick, instead of adding this 5, 6 values, what I am going to do, probability of x greater than 1 is, x greater than 1 means 2, 3, 4, 5, 6, 7. So total probability is 1. So that means what I understand here, probability of x greater than 1 plus probability of, okay, I'll write it. So probability of x greater than 1 means probability of x less than or equal to 1. This is the total probability, right? When you add this both, you will get 1. So probability of x greater than 1 is less than or equal to 1. When you add this, you will get 1. So using this one formula, there is nothing different, guys. Just one formula. I am going to take this in the other side. So probability of x greater than 1 means I am going to take x less than or equal to 1. So why I am taking this? Now the formula is very simple, students. You see, x less than or equal to 1 means we have 0 and 1. Add these two probabilities and then subtract with 1, you will get the answer equally. Now you understand if it is 7. Suppose if it is 100 means it is very tough to add all the 100 values. So if we have to make shortest thing using this total probability, that is sum, this total probability is going to be 1. Using this trick we are going to form the formula. I think now you understand, guys. Now let me write all the formulas, possibility things. So probability of x less than a, I will put some number that will be better for you people instead of confusing you, is going to be 1 minus, so whenever you see less than, put greater than or equal to. Is it clear? So when you have greater than here, then 1 minus probability of x less than or equal to. Okay, you have to write this clearly. Okay, similar thing, if you get like this, then 1 minus probability of x greater than a. So using this, we can enjoy a lot of problems. Very easy way. Okay, so keeping all this data in our mind, let us go to a simple problems. Okay, before going to problem, I want to say two more concepts. So we know that sum of the probabilities is 1. Now, according to the distribution, so we have table. Just now I said you how the table comes. Okay, here we have x and here we have probability of x. So x1, okay, x1, x2, x3, it goes on. Correspondingly, we have probability of x1, probability of x2, probability of x3, it going on. So now the sum of the probability is 1. Now the next question is, what will be the sum of probabilities of xi, and if we multiply this corresponding xi. So probabilities of PMF with xi. So this is the invention of a new data. This is, people say this as expectation. This is called as expectation of x, and people, this is your mean. In unit we have learned mean, right? So mean of x, or we can say this is expectation of x, guys. Now you understand this expectation of x, or people say mean of x or mean value of x, all are same. Okay, so now we have learned the concept to, like the new one, this topic is expectation. So how the expectation comes, you take the table, multiply each column x with p of x1, x2 with p of x2, and when you add all these things you will get the expectation or mean value of the given problem. Okay, this is done. Now some properties, because in exam point of view we need some properties to be used and crack the problem very easily. So what is this? E of C. C means a constant, a number, any real number. Expectation of constant is going to be, the expectation of constant is going to be the same constant. Okay guys, so expectation of constant is going to be constant. So unofficially you can remember, like if something is constant you cannot expect anything from that, right? If something is moving, something is, you can expect changes, right? From the hill you cannot expect any change, it is a hill, right? From a big stone it will never move, it will be always stone. So expectation of constant is, okay, this is mathematics, okay, just for your exam point of view I am just saying expectation of constant is always constant. The next formula if you remember, then problem over. So suppose now there is expectation of constant into a random variable, then this will come out. So E of AX is going to be A into E of X. These are the two properties, students. Now this is the extension of this property. People say this is AX plus B. So B is constant where A and B are constants here. So in this case what you have to do, this satisfy linear property. Almost all the functions satisfy linear property. Expectation of constants is constant, and this is going to be A into E of X. Is it clear? So you have to remember this for solving problems. So we have learned what has been the expectation, and the final concept called variance. So variance means you should not think square of expectation or something like that, okay? So people say var x, this is, or simply v of x, or okay, there are different formulas, different versions. It will give the same answer. I am going to give you simplest one. E of x square minus E of x whole square. This is going to be your variance. Okay, so for finding E of x, what we are doing, I am taking xi, probability of xi, and I am taking x square, xi square, probability of xi. If you want to find x cube, xi cube into probability of xi, this goes on. So you can take this easily from the table, you can find 1 and 2. E of x square minus E of x whole square will give you the variance. If suppose people are asking standard deviation is nothing but square root of the variance. So it is very simple, guys. So for variance you need to know what is E of x and E of x square. So similarly now I will compare this properties. Okay, so C is constant. Okay, here I am taking A, B, C or constants. Not is. So they are all constants. Now I am going to compare E of x and V of x. So this is x. So E of x is nothing but expectation and V of x is nothing but variance. Okay, so we know the result. Expectation of a constant is going to be constant. So variance is little different. Since the syllabus, in our syllabus it is not given, so I am directly giving you the formula. In our syllabus we don't have derivation. Variation of constant is going to 0, right? Then expectation of random variable with constant will give you A into E of x. Here variance of AX will give you square of that constant into variance of x. If you remember this, then problems are very, very simple. Okay, so let us see in general. So expectation of AX plus B means it satisfies linear property. You will get E of B. That E of B is nothing but B A into E of x. While you go for variance of AX plus B, now what will happen? Variance of constant is 0. So this part will 0. AX I will get A square into variance of x. That's it, students. So if you remember these formulas, like we can crack the problem like anything. Problems are nothing to worry. Okay, so let us see the problems here. Okay, I will take a simple problem because this being the first session. I will take a very simple problem. Let us crack this in our own way. Okay, don't bother about the stories. If x is a discrete random variable they are giving you a table. Most of the times you will be getting a table. So once you see the table, you should understand it is a discrete random variable, even if it is not given in the question. 0, 1, 2, 3, 4. Limited data. Okay. Yes, so this is the table. So whenever you understand, whenever there is tabular version is given something, they will tell you to find 100% is going to be discrete random variable. A, 3A, 3A, 5A, 7A, 9A. So what are all the questions they are going to ask for us? First they are asking find A. So even they didn't tell this find A, we have to find A because then only we can able to answer the values, probabilities. Probability of 0 less than x less than 4. Find the mean. So mean you should not worry, that is nothing but your expectation. And find the variance. Okay, find the variance. And one more data, they can give anything. Okay, so for your understanding, I am taking all kind of possibilities in simple problem. Variance of 3x minus 4, etc. Okay guys, if you, and one more thing here. Okay, 7 I would write. Probability of x greater than or equal to 3. If you know this, then easily you can crack the problem, guys. So it's so simple, nothing to worry. Let us see this. Let us see one by one. So first, how to find this A? So that is the question. Okay students, now let us do the problem one by one. So first problem is we have to find A. Okay, this is probability of X, each event. So we know that sum of the probabilities is always what? 1. So we begin the game with this formula. If you know this one formula, you can play a role, like you can do all these things easily. So sum of probability is 1. So now what are the data we have here? A plus 3A plus 5A plus 7A plus 9A is 1. So now easily I can find this is 25A equal to 1 and finally A equal to 1 by 25. Done students. So first problem is successfully completed. Let us take the second one. What is the probability of X lies between 0 to 4? You see, in discrete it is very important X less than or equal to A and X less than A, they are not equal, okay? You should be careful. So now 0 to 4, between 0 to 4 means I have to neglect 0 and I have to neglect 4. So the data remaining are 1, 2, 3. Okay. So just like that I have written. So you can see how to crack this problem 2. Problem 2 you can easily crack like this. 0 less than X less than 4. So that means 0 and 1 are eliminated. 0 and 4 are eliminated. X equal to 1, X equal to 2, X equal to 3. So what we have to do now? Probability is 3A, 5A and 7A. So total data is going to be 15A. So let us keep like A, okay, don't substitute the value and get problem complicated. Finally we know A value is 25, 1 by 25. So the answer is 15 by 25. So what we can say, this 5 will get cancelled and I will get 3 by 5 is the probability. Hope you understand and you're enjoying how to solve this problem, guys. Now let us go for the third one. Okay, side by side I'm not writing organized way because I'm giving you a material where it is everything is written properly in an organized way. So probability of X greater than or equal to 3. Because now I can see the question and answer together, that's why I'm writing like this. So greater than or equal to 3 means 3 should be included as well as 4 should be included. So probability of X equal to 3, probability of X equal to 4. So this case is very simple. 7A plus 9A, 16A, A is 1 by 25. So 16 by 25. You see? Okay, we have did this. So these are all very easy. Next one you see guys, mean and variance. So let us make the table together, then it will be easy for you people. So mean and variance. So we know the formula. Okay, let us go to the fresh side. So mean E of X and variance W of X. So that is going to be E of X square minus E of X whole square. So expectation is sigma xi into probability of xi. So now what you have to do, this is my x values. Okay, let us see. From the table I am making a new table. So I am writing vertically for my convenient. If you want you can write horizontally also. 0, 1, 2, 3, 4 and your probability just now we have found. So that is A equal to 1 by 25. So A, okay, 3A, 5A, 7A, 9A. So we need X into P of X to get expectation. To get variance, we need x square into p of x also. Okay, so what I am going to do, so x in this is going to be 0, 3a, 10a, 3 sevens are 21a, 4 nines are 36a. The next one, x square into p of x means we have to square this. Again, this is 0. 1 square is 1, 3a. 2 square is 4. 4 5s are 20, 20a. 3 square is 9. What is 9 sevens are, guys? Yes? 63a. And 4 square is 16. 16 into 9 is 144a. That's it, guys. So now, for your convenience, you can see a is going to be always 1 by 25. So now if you add this, you will get sigma x into p of x. So a is going to be common, right? So 21, 36, 10. So this is 3. Yeah, because it's some error. So now you can see this is going to be 70. Am I right? Yeah, 50, 60, 70. So now we know the value. This is nothing but 70 by 25. Similarly, e of x square. This also we need. So e of x square, 144, 63, 23 is going to be. You just use your calculator, guys. Don't lose marks by doing silly mistakes. So now you see e of x we have calculated 70 by 25 because it is 70a. E of x square is 230a. A is 1 by 25. So e of x and e of x square we have calculated. So this is my answer for 3. This is e of x or mean or expectation, etc. Okay, now for this case what I am going to do, for 4 I need variance. So variance of x is e of x square minus e of x whole square. So we know that e of x square is 230 divided by 25, and here it is going to be 70 by 25 whole square, guys. So what you have to do, just take your calculator, don't get panic, you can easily find the solution. And listen students, this expectation variance need not to be lies between 0 and 1. Only the probability lies between 0 and 1. Okay, that's it, guys. You see, we have completed the problem. Now you can go to this guy. What is this guy? E of 3x minus 4. So what is 3x minus 4? Just now we have learned the formula. It is going to be, so when you multiply with constant, it's going to be 3 times e of x minus 4. Expectation of constant is constant. Just now we found e of x. What is our e of x? That is going to be 70 by 25, guys. This is minus 4. Again you take your calculator and find the value. I'm just writing. When you take LCM, you will get 110 by 25. Further, if you simplify, you will get 22 by 5. Similarly, final one, variance of 3x minus 4. As I said, variance of constant is going to be 0, and 3x means 3 square into variance of x plus 0. So 9, and variance of x is 70 by 25. Okay, so just multiply it and substitute the values, guys. Okay, sorry, one second. For this is not 70 by 25. You have to calculate variance. Just we have found the variance already here, right? It's going to be 34 by 25. You have to substitute 34 divided by 25. That's it, guys. So it's very simple. Okay. So finally we have one thing. If people tell you to find distribution function, okay, distribution function or cumulative distribution function, CDF, don't get scared. It's very simple, guys. You have to take the table, just copy the table 0, 1, 2, 3 and 4. And this probability mass function, we have A, 3A, 5A, 7A and 9A. So now again substitute the values. What is the values here? Yes guys, yeah, is 25, 1 by 25, 3 by 25, 5 by 25, 7 by 25, 9 by 25. Now you see, just write like this. If they ask you to find CDF, make a table and say from the table we can find the cumulative distribution easily. Okay. But the important thing is to get score, you have to write the formula. This is capital F of X. So now you see, as I said, it starts from first value. What is your first value here? 1 by 25. So just write like this. So once you did the first value, add this cross. 1 plus 3, you will get 4 by 25. Then add here. 5 plus 4, 9. 9 by 25. Then add with this 7. So 16 by 25. Then add here 16 plus 9. 25 by 25. As I said, always the end value should be 1. And here it need not be 0. Less than or equal to 0. If you get 0 or more than 0. Because we know the property f of x lies between 0 to 1. So the starting value may be 0 or it may be any positive. But understood that ending value is always going to be 1. If someone asks you in the examination, find the CDF, just make the table and say from the table it is easy to find the cumulative distribution function. Okay. So the actual method is also correct, like we have to calculate one by one, but it is lengthy. You may do some writing mistakes or calculation mistake. So this is the easy way, guys. So here we stop the random variable. A simple introduction in this today's class we have seen, as well as we have seen some other concepts called like expectation, what is mean and variance, and how to see the properties and calculate the properties in the simple problem. So in the next session we are going to take a similar problem and we are going to explore more using conditional probability. So there are some problems with conditional probability also we are going to deal, that we can see in the next session. Thanks for your patience, guys. See you. Bye bye.